typically when 5-axis machining, we want to minimize the amount of rotary axis movement as much as possible, as this will generally give much more stable cutting conditions, which in turn will improve our surface finish, and generally our overall feed rate will increase as we're minimizing any deceleration and acceleration of those rotary axes. So to help us achieve this, a new option has been developed on the Toolaxis definition form that allows us to lock one of the rotary axes of the machine. So we're going to load in an example and go through the procedure of locking one of these rotary axes using this new option. So I have 3 toolpaths already created. One has already been calculated and 2 are batched, ready to calculate. The first toolpath is a simple constant Z toolpath. You'll notice that we've also used automatic verification to remove any collisions with the shank or the holder using the displayed parameters. So if we zoom in, you can see quite clearly here that the constant Z toolpath is incomplete. There are large sections that obviously collide with the shank and the holder, and these have been removed by the automatic verification. So let's just bring our machine tool back and simulate from the start and display the machine axis information. Just pause the simulation and increase the simulation speed. So you can see, as mentioned, it's simply a 3-axis toolpath with a vertical tool axis, so there are no B and C axis movements. An ideal way of machining this part would be to tilt the head over at 45 degrees to allow the tool better access to the part without colliding. So now we're going to use the new fixed tool axis option to force the head of the machine over at 45 degrees and lock one of the axes of the machine. So if we go to the settings for our second toolpath, on the tool axis form there's a new option under the definition tab. You see our tool axis is still set to vertical, so 3-axis machining, but then we're telling it to lock, in this case, the elevation angle to 45 degrees. So in this case the elevation angle is the B axis, which is on the head. If we accept and calculate this toolpath, so you can already start to see that we're machining much more of the part than we did with the previous toolpath. And this time, if we simulate from the start and bring back our machine axis information, let's just pause the simulation and rotate and get a better view.